Okay, it's Tuesday, April 28th, and we're going to continue on electric and magnetic forces. Today we're going to focus on electric forces. In fact, this is a great GIF of lightning. And lightning is all about electricity and how there's a negative and a positive side. And so that's where this energy comes from. So in your composition book on page 77, you're going to take notes on electric forces. So electric forces is all about positive and negative charges. And what allows something to have positive and negative charges is whether it has extra electrons or fewer electrons. Now normally an atom likes to stay neutral. It likes to hold on to its electrons. But if an atom gains electrons, then it's going to gain a negative charge. If an atom loses electrons, it becomes a positive charge, and that allows these electrons to move around and allows objects to have negative and positive charges. So this slide shows you lots of examples of electric forces at work. So we can start at the bottom here. When you have a battery, the battery is set up where you have the positive side and then the negative side with extra electrons, and what those electrons do is when the battery is not connected to anything, the negative electrons over here can't get to the positive. There's something blocking it. But when you put it into your remote control or your appliance, then you get the circuit where the electrons find a way around to the positive side, and in doing so it creates electricity for you to run your objects. In your house, you have this thing called alternating current. That's the thing that you stick the power charger into the wall, and what that does is it creates an AC flow of electrons going back and forth, back and forth. Static electricity is really fun. It's when you have the electrons rubbing off of the balloon, and then so you get positive and negative, so you get this nice attraction. And you probably remember this famous story of Benjamin Franklin, who flew a kite during a lightning storm, and he had a key attached to it, and that allowed the lightning to hit the key and the kite, and he then thought of electricity in that sense. Because what lightning really is, it's a flow of electrons. You have, what happens is your cloud, you get the positive ions go towards the top of the cloud, and then the negative, heavier ions go to the bottom, and you get this difference of positive and negative, so therefore you get a electrical surge. Sometimes the electrons want to get to something closer. Maybe it's a tree in the field, maybe it's someone holding an umbrella or something like that, and the electrons will go to there, and then you get lightning strikes that will hit the ground. Okay, I'll finish off with a TED Talk, a video about static electricity, and does a great job explaining the difference between positive and negative. See you tomorrow.
Conductors like metals and salt water tend to have loosely bound outer electrons, which can easily flow between molecules. On the other hand, insulators like plastics, rubber, and glass have tightly bound electrons that won't readily jump to other atoms. Static buildup is most likely to occur when one of the materials involved is an insulator. When you walk across a rug, electrons from your body will rub off onto it, while the rug's insulating wool will resist losing its own electrons. Although your body and the rug together are still electrically neutral, there is now a charge polarization between the two. And when you reach to touch the doorknob, zap! The metal doorknob's loosely bound electrons hop to your hand to replace the electrons your body has lost. When it happens in your bedroom, it's a minor nuisance. But in the great outdoors, static electricity can be a terrifying, destructive force of nature. In certain conditions, charge separation will occur in clouds. We don't know exactly how this happens. It may have to do with the circulation of water droplets and ice particles within them. Regardless, the charge imbalance is neutralized by being released towards another body, such as a building, the earth, or another cloud in a giant spark that we know as lightning.